All right, let's kick this off. Welcome to this very last live stream. It's actually a very sad day because this marks the end of our live stream series. Yeah, the end of a good cooperation of Martin and myself. But first, before we really end the show, let's talk about today's live stream. Today, we want to talk a little bit about code release using pipelines, which means how do we actually release our code in a structured way to our Azure platform. And this is what we will cover in the next 45 or so minutes. All right, so let's quickly introduce ourselves, and we start with Martin. Martin.
Yeah, thank you for the introduction. My name is Martin Ehrnst, and I work for a service provider in Norway called Identities. So basically helping customers onboard the Azure platform or onboard other cloud platforms, but I mainly work on Azure. So also a technical lead a technical lead at Identity and user group, Azure user group in Norway, founder and that kind of stuff. Do some skiing and also some race car driving as well in my spare time. What about you, Marcel?
Well, before I introduce myself, let me ask one question, because this is the last live stream. What can you share a little bit more details about your race car driving experience? What you're actually doing?
Well, I own a race car and I do drive in a BMW Cup in Norway, so around 10 races a year.
Very cool. So kind of a semi-professional thing then?
That's an overstatement.
Okay, but sounds very exciting. All right. Yeah, I'm Marcel. I operate out of Switzerland, and I work for SoftwareOne. And my team and myself, we help customers with everything Azure and M365, so onboarding onto those platforms, and obviously building solutions that help the businesses becoming more successful. And one thing we heavily do and invest time in is everything infrastructure as code. And this also contains procedures and processes for releasing code using pipelines. So exactly the topic we will cover today. Okay, so we have only 2 bullets to cover. So one is code management with repositories, which is kind of the basics that people need to understand when it comes to releasing code using pipelines. And then the second is obviously the release using pipelines topic itself. They are related to each other, and you definitely need to understand both things when it comes to structured code release. So let's dive into the first topic. So this is all about code repositories. Now, what does that mean? I have an IT pro background, so I was an IT pro guy all my life. At least after I started my IT career. And I've done lots with scripting, and I helped lots of customers when it came to scripting things. So back in the old days when we talked about data center automation, those kind of things. And what I saw a lot is this. Kind of a not so cool view into a folder that obviously contains some scripts. And this is how script versioning was done back in the old days. And I would say not only back in the old days, this is actually still what some people or customers do. And as you can imagine, this is not really what it should look like, because it's very confusing. No one in this very simple example, no one actually understands what version of the script to run, which one is the current version that should be used. It's absolutely not clear. If you want to find out, you would need to dive into the different versions of the scripts and analyze and compare the code, and that's of course lots of work. And if you imagine that you deploy a full platform as code, and you end up with this totally confusing naming of your code and versioning of your code, then well, the risk is very, very high that someday you will mess up your whole environment because you might pick, well, the wrong version or something. So this is not what we want. So there are some challenges, what we've just seen. We need to make sure that we can track code changes somehow, that we can easily see who made changes at our production code, at what time, what exactly was changed. And we also need a way to find out how to manage conflicts. This is especially important if you have multiple persons working on the same code, because it's possible that, well, two team members work on the same script or the same ARM template at the same time in different sections, and then we need to understand how these conflicts get resolved. So we need some way to deal with that. And of course, if we somehow break our code, we need to be able to roll back to find a version that obviously still worked, right? So that we can easily get back to a working code version. All right, so now, how can we address this, or are there any tools available? And the answer is yes, of course, there's many tools available. And one that we will just use and introduce today that is heavily used, I think by far the most important and famous one is Git, which is an open source software, totally free, and allows you to source control and version your code. And that definitely helps you to manage your ARM templates and also to extend the quality of your ARM templates over time, because you are in full control of this. Now, Git uses a distributed system, which means that once you start using Git, you will create so-called repositories that then contain and track your code. And these repositories can be distributed. So you normally have some central place where these repositories will be stored. So let's say on a server or on some platform, and then whoever wants to work with that code can then pull down a local version of it. So you'll pull down the repository with all the content. You can start working with that files or ARM templates locally, and once you're done changing the code, you can push it back. So this is how Git works. Good. Now, of course, we need to make sure that the code that lives and is tracked in a repository is somehow protected. And for that, Git offers a process called branching. And branching means that you can have multiple branches to manage your code. So whenever you start working with Git, you will have this master branch. And the master branch is that main branch that should contain code that really works, that is tested, that is verified, and that, well, normally is deployed onto your production environment, right? And now, as you know that this code really works, before you make any changes to this, you can now create a second branch, which you can imagine is kind of a copy of the master branch. It's not really a copy, as you can see here. If you create a second branch, in this example, top right, you can see that new branch is called dev. It relates on the master branch, and now you can start making code changes, right? And if you're not happy with the result, you just kill your dev branch, and the master branch remains unchanged. However, if you tested your code and it obviously works, then you can merge back those code changes from the dev branch and merge it back into the master branch, which then means you have now a new version of that master branch that contains the new version of the code that, again, has been properly tested. Now, of course, you want to make sure that only people that, well, are somehow responsible for this code are able to merge branches back into the master branch. And for that, you normally should protect your master branch by using a branch policy. So you can protect your master branch saying, well, there's no way that someone can directly modify code that lives in the master branch. So people that want to make code changes, they need to create a new branch, change the code there, and then they cannot just simply merge that branch back to the master branch, but they need to create a so-called pull request. And the pull request means, please pull the changes from my dev branch back into your master branch. And then obviously some person needs to quality check that code and then make a decision if that merge should happen or not. All right, so this then also follows kind of an approval process to protect your code. So as I said, Git is open source. You can download it for free. That's done in a minute or two. And if you're looking for a platform where you can then store your repositories, there's like two very famous platforms. One is Azure DevOps from Microsoft, and then GitHub, also from Microsoft. These are two platforms you can use to well, store your repositories, share your repositories if you want, and make it available to others. And of course, beside those two, there's many others, but I guess these two are the most famous ones. So I suggest to have a first look at Git and how to manage code in repositories. Martin.
Yeah, we could try. This is, as you mentioned previously, heard that this is exactly the IT Pro, what we used to do back in the days, but we kind of have some knowledge of this this stuff now. So if I can share my screen, then I'll kind of start off by what I tend to do when I'm starting off with Git and source control for my code, and especially what I used to work with is ARM templates and Terraform templates and that kind of stuff. So I always start off by creating. You can of course do everything with code that I am doing now, but I try to start off by using the platform, the visuals of the platform. So first off, I want to start to work on this repository that we have used throughout these live streams. And like Marcel said, I need to get this code down to my computer, and then I can start working on it locally, and then I can kind of make my changes with a pull request and that kind of stuff. So I'm going to show you what we are going to start off with. So if you find or if you create an empty repository, you can do that from the platforms itself, or you can clone some of the some existing repository like I do now. So I want to have these files. I want to use these deployment scripts or these templates in my pipeline later. Then I need to make some changes. So first off, I'm going to copy this URL, and then I'm going to use Visual Studio Code to do a git clone, and then I can use the URI and clone that repository down to my computer. I need to select the folder where I want it, so I can put it in my documents, for example. Now I have a copy of this of all this code that I found on GitHub. I now have all this on my local computer. So if you go back here, we can see that I have something called advanced templating, CI/CD, deployment scripts, linked nested, and so on. And now I have the same stuff here. And if I want to create some or do some changes here, I have already a protective, this master branch that Marcel also told you something about, is that this is protected from directly editing. So I can't do edit on the master and then directly write back to the master branch. I will need to create what is called a new branch, and I can call that, for example, dev. I'll do all my development in this dev branch. So going back to the image that Marcel had in the slide deck, there you can see that I'm kind of making a new, from the tree I am now branching out, copying the code, so to speak. Then I can do the changes that I want. So making my changes and saving it. And then there's another thing that we need to do, and that's after the changes is, after we have done our changes, we need to do something, what is called a commit. So I'm doing a commit, and I have to add a message to my commit. So I have made changes. That's my message of the changes that I made. So usually, if this was production environment, you should probably write something about why you changed or what you changed. But then you can, first off, we need to publish the repository and push our changes. So now we are syncing our changes back to the remote repository, which is in GitHub. And as you can see, that I have my dev branch has recent pushes less than a minute ago, and I can compare these changes with the master branch, so I can see everything that was changed on the README file from the master to the dev branch. And by doing that, we can kind of validate the code and see if anything will break during our deployment and that kind of stuff. So now I can create a pull request. And that means that what that essentially means is that we need to, since I have a block here, I need to review the code change, and Marcel should be the person that was actually going to review the changes, but in this case, I am the only one who can actually do this. So I have to use this function that I have to review my own code, but you get the point. So the master branch was you cannot add changes directly to the master branch, and it is also protected in a way that when you need someone else to review the code. So once I confirm this, I can merge these together, and then the master will now have the changes from the dev branch. So if I switch back to master here, you can now see that it has detected that it has two changes remote that I haven't synced locally. So we can do a git pull, and now we have that line of text in our master branch on our local computer as well. Anything else you wanted me to cover for the first demo, Marcel?
No, that was a very good demo, and it clearly shows that well, this actually puts you in control, and it definitely helps you to protect your code, no matter if it's ARM templates or if it's other code such as scripts or whatever. It doesn't actually matter. And maybe just one addition to what Martin showed you. He showed you how Git works inside Visual Studio Code, because well, this is kind of integrated into this IDE, and it's just our most favorite tool, of course. But Git also, of course, works without Visual Studio Code, so you can use it as a command line tool and also manage your code from there.
Yeah, that's true. So you can, of course, from the command line within Git, Visual Studio Code as well, you can do kind of like Git commit and those kind of the same commands that you can do through the user interface or the GUI interface. So you have to install it, install some extensions and that kind of stuff in order to have this to work, but it's all self-explanatory at during install.
Yeah, so really just go to the Git website, download your Git version to your box, and then start using it. I think that's really important. Also, I mean, this used to be like a dev-only thing back in the days, but today, actually, every IT pro guy should also use Git or of course, some other source control management system to manage his or her code. All right. So that was the intro that is well needed so that you understand how this part works to manage your code properly. Now let's go back to the presentation and dive into the second part, which is all about release pipelines. Now, what does that mean? Now imagine you have your code sitting in a Git repository and you want to release it to the Azure platform, right? What does that actually mean? Now, first, what we need to ensure when we release code to our production platform is want to make sure that every single release is absolutely identical. Of course, not from a code perspective, because the code might change, but the process to release the code should be always the same. So it's normally not such a good idea to release code directly from your notebook, because if maybe my teammate releases the same code from his notebook, the result might not be 100% the same, because there might be environment variables that are different on my box compared to his box, and we definitely don't want that. So we want to have a structured and 100% identical approach whenever we release code. So that means that we need to define some release process that lives somewhere where everyone that has permissions to do so can release code from, right? So this is really important. So some central place where we can define this release process for our ARM templates, right? And then of course we need to make sure that this process, wherever it lives, has the appropriate permissions, because we release ARM templates, and that means that this release process needs to access our Azure environment, or more specifically, maybe our Azure subscriptions if it's resource group based templates that release whatever, some resources to the Azure platform. So we need to assign proper permissions to that process so that it can actually touch and communicate with our platform, right? Now, depending on where this process resides, and we will, or Martin will show you later, Azure DevOps, how to use Azure DevOps for this. Then that means that Azure DevOps is a SaaS application. So it lives somewhere in the cloud. That means that if you start this process later, that someone needs to actually execute that process. And for that, you have so-called agents that will then trigger this process. And now, depending on your exact needs, there's different type of agents that you can use. So because Azure DevOps is a SaaS platform, it obviously also offers agents that will run this pipeline for you. And then those agents, of course, need the proper permissions to access your environment and then deploy the code from there. As an alternative, you could use self-hosted agents that live in your data center or in your Azure environment. This is normally used for, let's say, more advanced scenarios where you might need specific tools on the agents if you have, again, more advanced deployments. But I think Martin will cover the cloud-based agents here. All right, now the second thing that's important, if we have a release process, we of course want to release our ARM templates for sure, but why not integrate some additional steps there? And I think this is also very important because before you release code to your productive Azure platform, you should also make sure that your code, your ARM templates are verified, that well, you follow some best practices or something. So you should really check your code quality, check the code integrity and so on. And this can also be part of this release process. So before you release your code actually to the platform, you do some quality checks, right? And then, of course, if you have changed your code and you do your next release, you also want to make sure that this really, really works. And for that, you can also have so-called multi-stage processes, which means, well, in the first step, we will release our code to a dev environment. And then we'll see what happens. If this works as expected, if it fails, if the quality is good, if some errors have been thrown or whatever. And only if we're happy with the result, we can then continue the process, maybe after an approval step where some humans need to manually approve. And then the same code is released to the production environment, for instance. So it's in the same release process where we first deploy to dev and then maybe later into prod. And as I mentioned, we can have specific quality gates saying, well, once we have the code released to dev, we will do some checks. And these checks can, of course, be manual checks, but they can also be automated. And the quality gates I mentioned also means that we can check certain situations in that dev environment. For instance, we could check Azure Monitor if specific errors or alerts have been thrown, or we could check the compliance status if that has been changed after our code release. And if so, we can stop the process there, and we then first need to fix those issues in the code before we do a next release. So those kind of things can be defined in that release process. And we, I mean, the more we can automate, the better. And our aim is to really automate that full process so that we can actually start that release. Also automatically, whenever new code is, for instance, pushed into one of our branches, then we could automatically start a release process until our code at the very end hits our production environment. That would be our goal. All right, as I mentioned, the pipeline, or more specifically, the agent that runs the pipeline needs proper permissions. So it needs to authenticate against our Azure environment. There's multiple ways to do so. For instance, you could use service principals or managed identities or something. Depends a little bit on the platform you use. And also the, well, the type of release you're planning. And I mean, if you have a pipeline-based approach to release your code, you should also already think about the next step and then start removing deployment permissions for humans. Because in a perfect world, everything is released as code only, and no human will have access to your platform. That's also a thing that, if done properly, can make your platform much more secure because humans need less permissions. But of course, that pipeline might need certain passwords, secrets, keys or something. And so it also needs to someone handle these. So it's possible that the pipeline needs to connect somewhere, and for that needs kind of a password or an application secret or something. And then this is normally also stored in the Azure platform in some key vault, for instance. And then you can authenticate the pipeline against the key vault and then get access to all of those secrets as well. So they're safely stored into the Azure platform. You have a proper permissions designed so that the pipeline can actually access the secrets and keys it needs, and nothing else. All right. Then I suggest that Martin gives us a nice demo about pipelines in Azure DevOps. What do you think?
Yeah, I think I have something to show, but I also have a proposal, and I think that we should do, you kind of not like name dropping all the advanced features that you can do during deployment pipelines. And I think we should, if you're up for it, I think we should do a live stream on that alone. So more advanced stuff. So
yeah, I fully agree.
Yeah, for this purpose, I am going to show more of the kind of like the basics of the basics that can work in a production environment.
Mm-hmm.
I'm going to pull up my screen again. So I've been invited to Marcel's Azure DevOps instance for this purpose. And what I want to do is that I want this repository to that we cloned to my computer in the first demo. I want this to be deployed to my Azure environment. So I want some of the code that we have used in our earlier live streams. I want that to be, instead of the pushing or instead of deploying that from my workstation, I want to have a pipeline do the thing for me. So for that, I will actually need something called a pipeline. And since Git is open sourced and now GitHub is acquired by Microsoft, there's a lot of integration between them. So, but you can create Azure DevOps pipelines for all the other platforms as well. So, for example, Bitbucket or other Git, that could be anything from an on-premises system, or like GitLab on-premises or something like that. But I'm going to use GitHub, that is hosting our repository from earlier. And now I have, since Microsoft is now acquired GitHub, it automatically discovers my repository. So that made it a little bit simpler. So the ARM templates repository is where I'm going to start. And now, if I had already had a pipeline in the, let's say, within this folder or the top level folder, it will automatically discover that I had a pipeline here. So then it will just say, do you want to use the pipeline that we found, or do you want to pick something else? But since it's hidden in a subfolder, I will need to browse to it myself. So you can see that it is within CI/CD folder. I have something called Azure Pipelines.yaml. And if you thought this was going to be easy to, you are dead wrong. This was not easy to me to understand at first. So, but what it is that the pipeline itself is handled as code. So once you expand your infrastructure deployment, you can also add the additional steps to the pipeline within this same pull request, for example, and then everything will be updated at the same time. So in all its essence, it's structured like Marcel's example in the slide deck. So I have 3 stages within my pipeline. I have a stage called build, and then I have a stage called test, and the test here is the simplest test that you can do in my opinion, is that it just verifies that the ARM template will work. Basically, it doesn't do any extensional testing. It just runs through the deployment without actually doing a deployment onto the Azure platform. But it will verify that your deployment, as in terms of ARM or Azure, will work. And on the release stage, I have added in a dependency for the test. So if the verification of our template fails, it will not start the release stage and the deployment jobs. And down here, I have the file for my deployment. I have my Azure deploy.json file, which is the linked and nested demo that we had, or the live stream examples that we had. But I have changed the actual parameters file and put that in a separate folder for it, because I wanted to change the names. So I'm using an existing old, so to speak, template, but I'm passing in the new parameters for this live stream purpose. And I can show you that Marcel said that in some cases you probably will have to handle secrets in your pipeline or in your scripts. So one way to do that, if you need secrets or credentials or something during ARM deployment, you can have your pipeline access Azure Key Vault, for example. But you can also, in its simplest form, you can also add in secret variables within the pipeline environment. So you do not handle the secrets as code, but you have to put it in as a variable. So I will need to do this for my subscription ID. So let's just call it the secret subscription ID and pass that in as a variable. Then I will need to find my subscription ID here, which isn't exactly that secret, but let's just keep this value as secrets and then press OK. So now I have within Azure pipelines, I have something of a variable that I can. So if the subscription changes, for example, I don't need to push that into my code repository, for example. So now I'm fetching my YAML pipeline from my GitHub repository, and I'm creating an Azure pipeline and running it on Azure DevOps. So it will start with, of course, the build stage, and it will continue to do the test, which is just the ARM template verification, and then it will release the storage accounts actually from the previous demo onto my Azure environment. So build did complete, and then it will, what it is in this case is actually just create an artifact from the repository. So it will just create a folder of the templates or the files that it found in our repository. If you had, for example, a web application, that step would also compile, for example, a .NET application or something like that to release later onto your web app infrastructure. I'm not sure what happened here, because it says that something went wrong, but the test stage actually. So that's interesting, but let's see how everything comes through. So now it is connecting to, I'm going to show you a little bit later, but it is connecting to my Azure environment. And it has deployed or downloaded the artifact, which is a bunch of JSON files. And then it is, as it was defined in my pipeline code, it is using these files for the deployment. And I also forgot to show you that, but I'm also adding in a name for the deployment. So in this case, I am using a built-in variable within the pipeline ecosystem that will add in a build ID to my deployment. So that will change each time you do a build or each time it does a release on the platform. Apparently it is finished. So let's go into my subscription and see. So you can see that the CI/CD here was the deployment name, and it was succeeded. And you can see the template that is actually deployed, which is the same template that it is stored in my GitHub repository here. So this one, I think, which is a nested template. And now it's deployed on my Azure infrastructure with a release pipeline. So let's see the resource groups, CI/CD demo, and here it is. Storage account CI/CD demo 0 to 4. So 5 storage accounts deployed using the pipeline. Anything I have not covered, Zo?
No, I really much like the demo. Thank you so much.
It was one thing. It was the connection to the Azure environment, actually.
Oh yeah, maybe. Yeah.
Yeah. So in this case, this is a proprietary setting for Azure DevOps, but it has something called service connections that you can use for one pipeline or multiple pipelines. So, and in my code, I have referenced the name of the service connection. So that's how it actually runs. So it's basically what's called it's not a managed identity, but it's just a service principal that I created during the app registration and basically a service principal. But you can also use managed identities for the same kind of thing.
Yeah, and with that, we can also make sure that your client ID, client secrets, and so on, don't end up in your code repository. Hopefully.
Yeah, yeah, that is one of the pitfalls of Git. That's you need to have some kind of structure on how to handle secrets, because otherwise they are going to be pushed to a public repository at some point. Oh yeah,
exactly. And there's lots of examples out there where you can actually get some kind of credentials to access someone else's environments.
Yeah, correct.
Which of course we never do.
Hopefully not.
All
okay,
right.
That was everything I had.
Cool. Super. Thank you so much, Martin. That was very interesting. Now I can imagine that this was a little bit, if this is totally new to you, this is kind of, well, it looks very complex, and yeah, I can ensure it is also pretty complex. well, you need to go through a learning curve to actually understand this, but you can start with super simple examples. And now the cool thing is that if you go to Martin's repository, you also have a very good example that helps you to kickstart your code release pipelines journey. All right. Let's see. For some reason, my screen is not yet shared. What's wrong? Need to push the button here. There we go. All right. So that was it. Maybe quick recap. Yeah, we really suggest and encourage you to control all of your code, no matter if it's ARM templates, Terraform configs, if it's PowerShell scripts, Azure CLI scripts, whatever you use to automate your environment. Use a source control management system, Git or something else, to really get in control of your code. And then to release your code, especially now focusing on ARM templates, make sure that you have a very structured process that contains all the different steps that you need to properly quality check your code, to then maybe release your code to some dev or staging environment before it finally hits your production environment. Because remember, if you use ARM templates for the full life cycle of your services, it means that you always go back to your code for every single configuration change and then release the same code to your production environment. So every time this generates kind of a risk, and you want to make sure that your code is rock solid and tested before it hits the production platform. Use the toolchain of your choice. It doesn't matter if it's GitHub, Azure DevOps, or anything else. We normally suggest that the customer uses the toolchain or the tools that he's most comfortable with. It doesn't really matter what it is, as long as the functionality is there. And again, the customer can handle the toolchain to manage and release the code. And if you're an IT professional, I think this is definitely something that you need to invest in. For lots of IT pros, this is kind of a new approach, a new way of working. But I think this is the future as we go more and more into a world where we manage everything as code. These are like your basic procedures you need to understand, you need to master if you really want to do this in a professional and let's say in a professional way with good quality or with a certain quality. So we really think this is absolutely needed to be able to master today. All right. If you want to again play with all the code that Martin showed you, go to this this URL. This gives you access to his repository. It's publicly available. So you can get everything from the very first live stream now to this very last live stream. So all the code is sitting in there. Thanks again, Martin, for sharing this. I think this is very valuable for people that start their ARM templates journey. And then also for the very last time, please make sure that you visit those two links. First, this gives you some information about Azure DevOps, how you can use Azure DevOps, so things you'll learn today in this live stream. And then second, that Azure Heroes program that we suggest you have a look at, where you can start earning your badges, and you can of course learn everything about that great platform, Azure. And because if you do so, you can then win a swag pack from Microsoft, and it's offered and sponsored by Microsoft Norway. So thanks again for this. Yep, and that said, that's it. Thanks again for joining us, not only for today, but for the full live stream series. It was a pleasure also to you, Martin, to have the series together with you. I hope everyone out there. Yeah, thank you. I hope everyone out there learned lots of new stuff, and I'm pretty sure, I mean, the series is now over, but I'm pretty sure, Martin, that we'll be back with some other live streams sooner or later, I guess, right? All right. Dan, thanks a lot, and see you very soon. Thanks. Bye-bye.